welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice, host of House of ZK Radio. I'm joined here today with co-host Pavel and our guest Bobbin, who is co-founder of Miden. Thank you so much, Bobbin, for joining us today.
Thank you for having me. Excited to be here.
Yes, thank you. We're also very excited. I'm wondering, Bobbin, if we can first start off just like with an introduction of yourself, your background, what got you into the Web3 and ZK space.
Yeah, definitely. So I've known about crypto space overall since I think 2013 or 2014. I didn't really get seriously into it until maybe 2017 or 2018, but I really got fascinated around that time frame. And for me, I saw very early on, it became clear to me that this is a revolutionary technology that has very wide-ranging implications. But as I kind of I think I read Bitcoin white paper around 2017, and I actually understood it at that time, and then also looked into Ethereum and all that stuff. It kind of the two things that really bothered me right from the start, and one of them is looking at Bitcoin, I was this is never going to scale. This is never going to work. You can't run this on the 6 TPS per second or 20 TPS even that you could do with this Ethereum. And I was somewhat skeptical about the viability of the technology, although I loved the implications and the goals it was trying to solve. And the second thing that really bothered me was the lack of privacy. So the pseudonymity of Bitcoin or Ethereum and others, it was really something that I didn't think you could make it work at the level that where everybody started using blockchain. So for me, that was not clear how this was gonna get mass adoption without any real privacy involved. But then I was kind of bummed to learn about these two problems. But then I learned about ZK, and as I understood how ZK works, it took me a little bit of time. It is okay, now I see the path of how we can actually make blockchains ready for both scale and mass adoption from a standpoint of privacy. So those two things really blockchains and ZK clicked for me together, because I didn't think blockchains without ZK could actually even work or be useful kind of in the longer run. And so I spent some time just trying to understand ZK, learning, because I knew this is something that is going to be critical. I'm a software engineer by training, worked in software and had a startup before that, a Web2 startup. But I really got it deep into ZK and started. One of the first things I did around 2018, I want to say 2019 timeframe, is build a Stark prover, one of the first open source, or maybe even the first open source Stark prover. It was a proof of concept. It wasn't super efficient or anything of that sort. I built it in JavaScript which was a horrible language to choose for to program a performance ZK system. But for me, it was kind of a learning experience, and so I kind of started posting about my work on ETH Research, and then kind of got connected with the Ethereum Foundation, with Starkware guys, and kind of got into working on trying to make ZK more accessible. So one of the first things I worked on was ZK DSLs for Stark specifically, because this is a system that I understood pretty well. And then for me, ZK DSLs were still kind of too difficult to explain to people. At least the ones that I came up with. And so I was okay, ZK VMs is probably the next step. And so I think was at least prototype one of the first practical ZK VMs. It was around 2020, I want to say. And, it wasn't something production grade, but it was working. It was a ZK VM that I think, before that there was TinyRAM, but that wasn't really practical. With my approach, at least at the time, you had something that you could use. It wasn't Turing complete VM yet and all that stuff. And so I worked that work was sponsored by the EF, by the way. So I worked on the ZK VM, and then after that decided to go and join Facebook's crypto project at the time, Libra, and then it later got renamed to Diem. So I joined Facebook team, also working on ZK. I built one of the most performant Stark provers. Now I use Rust as a programming language. That was the much better choice than JavaScript for this high performance system. So I built Winterfell, which was the like one of the first open source performance Stark provers now. I think Stark stuff was still closed source at the time, and now obviously they have Stew, which is like even like quite a bit more performant than Winterfell. But at the time, I think Winterfell was like one of the few, if not the only options that you could use in an open source environment for Stark proving. So I worked on Stark provers while at Facebook, and then as we know, like for many reasons, but like Facebook's cryptocurrency was not allowed to launch, and so it would kind of became clear that the project is not gonna kind of really go anywhere. A lot of great teams split out like from Facebook at that time, and I myself left as well. I went to work with Polygon, so kind of continuing my work on ZK virtual machine. So this is the first time Miden appeared as a word was actually the name of the VM. So like because the VM was named differently before I joined Polygon, and then once I joined Polygon, we renamed it to Miden. And so within Polygon, I worked on Miden VM for the first year. And I was a co-founder at Polygon at the time, or one of the co-founders. And within a year, I kind of like got to a point where I said, okay, like, the last several years were me learning about ZK and then trying to build a performance ZK VM so that it could be used in a context of what I wanted to solve, like in the very beginning in 2018 when I learned about like all the limitations of existing blockchains and what you could do with ZK. And so now I got to the point where I have the tools necessary, like how would the blockchain look like if I were to build it around like a ZK VM, and this is where the Miden blockchain protocol kind of was born. It was about, I want to say 3 years ago, where maybe a bit more, where I first described how like this, the concept of Miden blockchain, or the edge blockchain as we now call it. And then, for the last 3 years, we have been working on implementing this. And earlier this year, so this was kind of incubated in Polygon, so I was a part of Polygon, as I mentioned, and then kind of earlier this year, a few months ago, we spun out of Polygon, so Miden became an independent project, still very much aligned with Polygon, but we're now working separately. I think developing this as Polygon was one of the most rewarding experiences that I've had. But now that we are looking at bringing Miden to market, it also makes sense to have a separate project dedicated to that. So that's a little bit of a lengthy introduction, but I think I covered all the bases.
Yeah, nice. And I really like how you always had the consideration and the prioritization in the user experience as well. Like, for example, when you first got involved into the space, you mentioned that it was a little unclear, especially like, for example, when you were reading the Bitcoin white paper, a bit unclear about more mass adoption because of the lack of privacy options and lack of scalability. And even when you were transitioning into your work with ZK, you first experimented with developing ZK DSLs for Starks, and then you found that the ZK VMs were a bit more optimal in terms of the developer experience, so you put your focus into that. So I really like how you always had the priority of the user experience, and that leading to greater adoption, also with the consideration of the practicality standpoint, the viability standpoint. So really like how that was a focus that you had for these years.
Yeah, I mean, for me, it was like clear early on that like if we want, this is an amazing technology which I would like people to be able to use, and like how do I get it in front of people in the use, in as easy to understand manner as possible. Like not a lot of people want to read through like ZK papers and even like code circuits and think about programs as circuits and all of that stuff. So for me, for example, the ZK VM approach became super clear like fairly early on. What wasn't clear is if you can make it performant enough where you can run it on a client side, and a lot of work for Miden VM specifically was like, can you actually run ZK VMs on the client side in a way that is, because a lot of the even early ZK VMs were mostly server focused, right? Because you had to have like half a terabyte of RAM to run it, and like it would run for, I think the very early ones took hours. Now we're down to seconds. But it still wasn't clear, and so like a lot of engineering and like design for Miden game specifically went into okay, can we run it in a browser? Can we run it on a mobile phone?
Right, and even now there's like the opportunities for that client-side proving, as you mentioned, which was a huge progression from what we had before. We didn't really think that that was too practical, but it's really exciting now that we can potentially run these larger scale ZK applications that are browser based or like even on a mobile device. So something that's not too like in terms of the amount of resources, like not too much, which is really great to hear. And I wanted to, I also wanted to hear some more about the motivation behind Miden creating its own general purpose rollup. So you mentioned that first the Miden VM came about, and then you had the question how a blockchain would look like building around a ZK VM. But wanted to hear more about also like the kinds of differences that Miden's edge chain has compared to some of the traditional chains. And I know you previously mentioned that some of the difficulties with the previous, or like not really previous, but say current designs of popular chains like with Bitcoin, like with Ethereum, for example, the lack of that built-in privacy, and then also some, especially with Bitcoin, some scalability issues. So wondering how that all influenced Miden's current design and the idea of an edge blockchain.
Yep, definitely. So I think, as I mentioned, like the core problems like scalability and privacy were always there, and the question was how to address them, right? So I think like the way I think about it, the core issue of kind of what I call traditional blockchains is that they were developed, almost all of them were developed before ZK was really practical. And so the design there reflects kind of the limitations of the kind of, okay, we didn't know about ZK, so we built it the way we knew how to build it. And in fact, before ZK became practical, that was like Bitcoin. You couldn't have done Bitcoin in a different way. You couldn't have done Ethereum in a different way. And the core limitation here is that how do you verify that the transactions are valid, right? So how do you figure out if somebody like transferred assets from account A to account B? How do we know it's valid? And the only way we know how to do it without ZK is through re-execution, right? You need to re-execute the same transaction to get the same result, and you say, okay, I've executed this, therefore I know this is actually correct. And this, basically, this is the kernel of why we have those two limitations, because to re-execute things, first of all, you need to know the underlying details of the transaction, so the privacy is gone. And the second thing is they actually need to execute all the transactions that people want to execute, and then this is very bad for scalability, because if you have like a billion people executing transactions and some of them are very complicated transactions and all that stuff, you just you can't do it in a single node, so to say, or a single block producer cannot realistically execute all of those transactions that are needed. And so, and again, I'm not talking about like simple transfers. Maybe you can do simple transfers, but as transactions go more and more complicated, like you can't, actual execution takes time. And so, because these blockchains were kind of built around re-execution, like adding ZK to the existing design doesn't solve much. Yes, you can add privacy, for example, to an existing chain, and like for example, Tornado Cash on Ethereum, things like that. But it will always come with some limitations. It will be always an additional step that you need to do, and it will cost more because it wasn't part of the original design. And so even if you can augment some of those things, they do come with trade-offs, and frequently significant trade-offs. Like one of the issues and one of the things I think why privacy hasn't really taken off in blockchain space yet is because previously it meant much worse user experience, right? You had to jump through more hoops, so you had to pay much more. I remember using Tornado Cash a few years ago, and I think the fees I had to pay were 100x of what I would have paid on Ethereum, right? And it was much more than in terms of hassle of how to do it. It wasn't too complicated, but it wasn't something that was okay, straightforward. And even for myself, who is accustomed with the technology and is willing to deal with complications, much less for kind of regular users. So when I thought about Miden, and once I have this performance ZK VM that I've kind of been developing over a couple of years, I thought about how would Satoshi design Bitcoin if he had a ZK VM? How would Vitalik design Ethereum if he had ZK VM available and performance ZK VM at the time? And so what we came up with is this concept of edge blockchain, where instead of the network having to execute all transactions, users can execute transactions locally. and then users can send proofs of execution to the network. So like actually a lot of the activity happens at the edges, and hence the name edge blockchain, where you execute your own transaction, you store your own state, you send the proof of the state transition and the commitments to the state to the network, and the network just verifies what happened. For the most part, there are some nuances and exceptions, but for the most part, the network just verifies what happened. And so this solves both problems almost at the same time. I mean, there are other problems that come up, but these two problems where you basically have unlimited computational capacity, right? Every transaction could, like a single transaction could attest to like a data center worth of computations, and from a network standpoint, doesn't really matter because I'm just verifying a ZK proof. And so, I could, like every transaction could be like 100 million gas, for example. Like, I mean, I'm exaggerating, but like you're constrained by kind of the hardware that you have rather than by the network capacity in terms of computations. And then you also, because you get this property where users can execute their own transaction and manage their own state, the network doesn't need to care about that. So that also gives you privacy, right? So you have an option to be private. You can put stuff on chain as well. Like in Miden, to be clear, you have an option to be public or to be private, and there's actually like an interesting set of trade-offs that you can do. Like you can have like a private account, interact with public accounts, and all that stuff. But I think what it is important is to set up the incentives correctly, because as I mentioned before, like if you add, let's say, ZK to an existing design, frequently it results in more friction and like worse experience and more fees and things like that. But in this design, you actually incentivize people to be private, because what you're saying is you can do transactions yourself, you can store the state yourself, or you can outsource this to the network. But if you outsource this to the network needs to do more work for you. The network needs to execute your transactions, the network needs to store your state, and therefore you will end up paying more. So it's kind of like it's cheaper to be private to be public, and you have to pay to be public. And this is, in my mind, like the right setup of incentives, where you have both options, and in some cases it may be valid. You want to be, especially if you have shared state, you can't really get away from having it available publicly until we get like performant FHE and all of that stuff. But shared state right now, like on Miden, for example, is a public. You can do it using public accounts, and so you have this kind of hybrid approach where you can say, okay, I want to be private. In some cases, I need to be public. Public use cases hopefully will be like limited to really when you actually need to be public and can't be private. And so that's I think the core premise of the edge blockchains.
Yeah, amazing, and really great to hear that you're thinking about the incentivization component as well. Oftentimes we see users sacrificing privacy for convenience. If they have to go through some additional steps, usually it's less likely for them to use an application and have that privacy component, especially if it requires more work on that side. But great to hear that the Miden team has a way to incentivize people to be private, and it's really interesting that it could be cheaper to be private rather than be public there, while also providing users with the choice to have both options as well.
Yeah, and also like a clarifying question. You mentioned that Miden is an edge blockchain, so clients are the ones that are doing the processing, but of course, you can store states directly on the network as well. So what are the, I would say, what is the process for users to be able to generate this? Do they need to have high computational complexity devices? Like you mentioned that the ZK VMs have you need like half a terabyte of RAM in order to generate it previously. What are some of the let's say like bounds to having these client side proofs?
Yep. So client-side proofs, and by the way, this is one of the reasons, for example, like something like edge blockchain in my mind wasn't possible 2 years ago, and even now, like I think we're on the cusp of what is possible, is because you wouldn't be able to execute this proof sufficiently on the client side, right? I mean, you could do some simple things, but now I think we're getting to a point where it is very practical. To give you concrete numbers, like executing a simple transaction and proving a simple transaction for my blockchain, on a laptop takes less than 2 seconds, actually like closer to 1 second. So you can prove it fairly well. And the RAM requirements are fairly low, like under 2 gigabytes. We can generate the proof with roughly 2 gigabytes of RAM and in 1 to 2 seconds. If we go to smartphones right now, it does take a bit longer. I think we're closer to like 20 seconds. Still low RAM requirements, but closer to 20 seconds if you want to generate the proof on like a mid-range smartphone. And we know how to get it better. I don't think we'll get like all the way down to 2 seconds. In let's say the next 6 months. But the solution there, and I think this kind of like goes to maybe like the way we think about incrementally adding more and more privacy over time, is like you can delegate proving, right? So like if I'm on a low power device, I can ask someone else to generate a proof on my behalf. Now I do need to give up privacy to that someone else, but this is only one entity that I need to give up privacy to. I don't need to give up privacy to the entire world. And so like you can imagine a world where there is delegated proving, where your wallet provider or whoever runs a prover, and you ask them to generate a proof for you, they send it to you, and then from a network standpoint, it looks like as if you generate. The network doesn't really know that there is a delegated proving involved of any sort, but you do have to give up privacy to that prover. Now, there are other ways to do it, and so like even this gives you a reasonable trade of saying, if I really want to be private, I can use a laptop. If I am okay with giving up privacy to one entity, I can still do it on a smartphone. We are working on a number of improvements that will, first of all, you can use T's, for example, for proving, and then even the other party doesn't know what they're proving necessarily. Second approach is like MPC-based approaches, although MPC-based approaches for Starks, I think, are still kind of early. I'm not aware of like yet of a scheme that like does it at a efficiently in the production kind of level, or production ready level, where you can generate a Stark proof in a multi-party computation setting. I think one of the other things that we are exploring also, and probably will have like even before we go to mainnet, is ability to delegate parts of the proof. So like I mentioned that like in this proof that we have to generate on the client side, to give more concrete numbers, it takes like 65K cycles for us to generate a proof. And this is like using a specific signature scheme. Was like a CDSA, it would actually be much closer to like 1 million cycles or whatnot. But the heaviest part of this proof is actually just verifying the signature. So if you can outsource just the proof for the signature to someone else, that will already give you like a huge performance improvement. But at the same time, the other party doesn't learn too much. They just like generating the proof for a signature over some hash, and they don't necessarily know the amounts or the tokens involved in the transaction, or who is even transacting. They're just knowing, okay, I need to prove that there is a signature over this hash, and maybe you leak some privacy to that, but like the amount of privacy that you actually leak with that setup is minimal, I think. And so this is one of the things that will do this shorter time frame, and then once the proving systems improve and once the hardware on the phones improves as well, we'll get to a point where you can actually don't even have to delegate anything. You can just run it locally. Maybe this is like 2, 3, maybe 5-year time frame, but in the medium term, I think it's okay. Like I think to Alice, to your point is like we do want to have privacy, but at the same time, I don't want to sacrifice user experience too much. And if it's like maybe giving up some privacy in some places, if it's on a temporary kind of time frame, I think that's okay, rather than trying to go for absolute privacy but bad user experience right from the start.
Yeah, it's really interesting that there's a hybrid, kind of like a hybrid approach involved. So you can give up some parts of privacy, you're able to delegate some parts of the proof. So it's not like it's either fully private or either fully public, which I think that's really great in terms of like its flexibility. And also adding on to one of your previous points for privacy as an add-on, like say as an add-on to another protocol, you mentioned that there's some caveats, like it would cost more, there's some additional overhead, the user experience is not ideal, some costs that you would have to pay on chain, it's quite expensive. But I was also curious to hear more about the trade-offs between a chain that's specifically built around a ZKVM, like what Miden has, versus an existing chain that comes to integrate with a ZKVM, like for example, Ethereum potentially enshrining a ZKVM for real-time proving. I mean, I would assume that there would be like less overhead if one were to build a chain-specific, like a specific chain integrated with a ZKVM, but maybe there's some other caveats like building your own developer user base, or like any kinds of like not being able to tap into, say, like the Ethereum ecosystem, for example, or the Bitcoin ecosystem. So wondering about the trade-offs between both of those approaches.
Yeah, I mean, the biggest by far downside of doing something like Miden is that you're building something entirely new, right? People don't know a lot, and like the usability aspect of it is like, I would be very honest, like it's poor early on, right? You don't have the tools, you don't have the ecosystem, people don't know how to use it. Like there's a lot of developers out there who understand Solidity and can program in Solidity, and there's a ton of tooling already developed around Ethereum, both to help developers, but also to have the applications and all that stuff. So by far the biggest downside is kind of like the stuff that you have and the familiarity that you have around existing systems. And it would be ideal if we could add privacy to Ethereum, right, in a way that allows you to modify the core protocol such that it allows something like an edge blockchain, but run on Ethereum or Bitcoin or whatever other chain. I think, and in all honesty, like that would have been, if I knew how to do it, that would have been my preferred approach as well. I think the core of the issue is that, like, I don't know how you would modify some, like an existing widely deployed protocol so deeply that to make it work in this context. And I'll give you a couple of examples where I think the limitations come in. For example, one of the things that I early on wanted to do is like to maintain EVM compatibility so that people could just write Solidity and execute on Miden. But I wasn't able to figure out how to do it in a meaningful way because of the underlying data models are very, very different. For example, Miden is a combination of like a UTXO-based model and account-based model. And so bringing in like, so how do you code this in Solidity is not clear at all. And there are some like deeper fundamental reasons for this. For example, the way you usually code tokens on Ethereum is you have smart contracts. And the smart contracts basically are giant hash maps, right? Where they have like a record of who owns what, right? So every time you send USDC, you need to update that smart contract saying I've moved my USDC from this account to this account, right? And this presents like a contention point, right? So like every time, like I can't generate a local proof of me updating USDC smart contract because if someone else tries to do the same thing at the same time, they will generate conflicting proofs. And so somehow we either need to sequence this between ourselves, which creates a huge coordination problem, or we just won't be able to use USDC smart contract, right? And so, like, how do you solve it? And so, like, to solve this approach, we needed to come up with a very different state model where it works kind of like integrate UTXO into it, and like very different asset model where I can send something to Pavel, and then I can send something to you, or you can send something to Pavel, and these transactions are separate. They don't need to touch the same state. But on Ethereum, how you can't do that because you only have one native asset and everything else is represented as smart contracts, and the smart contracts need to be updated every time I want to make an asset transfer. And so yeah, like as I mentioned, like I just don't know how to make it work. But like if it was possible, like obviously the huge advantage of existing blockchain is existing tooling and like familiarity to developers. We are trying to we're trying to think about this and like make sure that we don't create like too much complexities ourselves. So one of the things, for example, we decided to do with Miden VM is not to build our own language. I know there are quite a few projects that build their own languages, sometimes for good reasons, sometimes for not such good reasons. With Miden, we kind of looked very hard at that and saying, okay, building another language is going to be extremely difficult and it's not going to present like as good of a UX to developers as we would like. So our approach has been to build a compiler so people can write Rust programs. So Rust is a bit more flexible than Solidity, so you can actually modify Rust enough where you can still code in Rust and then compile it to Miden VM. Actually, the compilation pipeline right now, and I think the blog post is actually, well, by the time this airs, the blog post will be a couple of weeks old because it is coming out, I think, early next week, about like the version of the compiler where we can actually write smart contracts in Miden using Rust. that gets compiled to WebAssembly, and then WebAssembly gets transpiled to Miden assembly, which can then be executed by Miden VM. So we are trying to think of how we can minimize this novelty and newness, but it is by far the biggest kind of obstacle, the challenge compared to like adding something like this to an existing chain. But again, if I knew how to do it well on an existing chain, I would probably do it there.
Right, yeah, that makes sense. And I wanted to have a conversation a bit more about the design considerations relating to the type of model that Miden is using. So to my understanding, Miden is using the actor model, and you mentioned that there is the hybrid components of both using the UTXO-based and also account-based model, and compared to Ethereum, well, you mentioned for Ethereum, you just have that one native asset, and smart contracts need to be continuously updated as you're putting in transactions. But wanted to hear more about kind of the thinking or like the reasoning behind Miden adopting this actor model and using the concept of notes as well, which has that hybridity between the account and UTXO-based framework. So very curious to hear, like first, how that design compares to some other existing chains and what types of advantages that users can get through this specific architecture.
Yeah, definitely. So basically, the actor model is not something we invented, right? It's a well-known paradigm for like decades in kind of distributed and concurrent systems. I think one of the first times that I learned about actor model was about like learning how WhatsApp was built, because they built it using I think Erlang as a language, which is all actor model based, and you know, it has a lot of advantages of when you think about like a concurrent system as a set of independent actors that communicate with each other by passing messages. And so kind of when I was thinking about the design of like how the blockchain could work, that was one of the first things that like I started to look into more deeply, like the actor model, where exactly for the reason that I described like a few minutes ago, where we want to keep the state updates isolated from each other. So like, and we need this both for the purposes of scalability and privacy, because if I do want to generate like a proof of me changing something, it would have to be my local kind of actor, so to say. So like in our context, actors are accounts. So I can, to describe like how this works in terms of a simple transfer, right? So like the way I would transfer funds on Miden, let's say I wanted to send something to Pavel. I would execute a transaction that would update the state of my account and create a note. And this would be a transaction that I can prove myself, because it's, okay, I'm taking, let's say 10 USDC out of my account and putting 10 USDC into this note. And then in a separate transaction, Pavel can consume this node and move the 10 USDC into his account. So we kind of logically separate the two-state transition. Like on something like Ethereum, for example, it would be a single transaction which updates my state and Pavel's state at the same time. Like I think the analogy I sometimes use is that for me to be able to give something do a token transfer, I need to like basically take someone else's wallet and put money into that wallet. And while I'm holding that wallet, nobody else can put money into that wallet. At the same time, on Miden, I take my wallet, I put money in a lockbox, and then at a later point in time, the intended recipient of this money can come and open the lockbox and take the money. So this logically separates the state transitions. And this is exactly what the actor model does, right? So like a state transition of one actor is not related to state transition of another actor. They're kind of decoupled. And this allows us to create this independent proof. So we basically took actor model and added ZK proofs on top of them, where we made every actor, state transition of every actor ZK provable. So you actually don't need to say, okay, nobody else needs to re-execute the transaction that you did to an actor, because you can just send the proof and say, okay, I've updated the state of the actor. Here's the nodes that got created and all of that stuff. So in many ways, like it was a perfect fit for this like decoupling of state contention that addressing state contention and decoupling kind of state updates. And I knew about the actor model at the time. Maybe there was another approach, but it seemed like a logical or like almost a perfect fit for the model that we wanted to achieve. And I think the goals that I first described, like I want to have privacy, I want to have parallel transaction execution, and I want different. It shouldn't be just parallel where a single entity executes all the transactions in parallel. It should be multiple entities can execute transactions in parallel and they still shouldn't conflict with each other. So that was the goal, and I think the actor models works very, very well there.
Yeah, that sounds great. And it seems like you mentioned that you're able to create these independent proofs by being able to logically separate these state transitions so that the state transition of one actor is not related to that of another actor. So you can have these multiple different actors, multiple entities doing this kind of parallel execution. So that sounds like a very kind of like streamlined process. But I'm also curious if you can also talk about the role that these nodes play in privacy preservation as well. And maybe if you could provide a walkthrough of that life cycle phase of nodes. So you mentioned a lot about the consumption phase, but very curious to see like on the end developer side, what that life cycle would look like in terms of its creation, in terms of its discovery and other parts of that life cycle as well.
Yep. And so just to mention, like nodes actually implement as UTXOs, right? So like if you think about actors as accounts and like they need to exchange messages, and UTXO is a perfect model to fit into like this, how do we represent a message in this context? And so, and the reason why is that you create a node once and then you consume it once, right? So you don't want it, like the way to think about it is Miden accounts are long-lived objects and nodes are short-lived objects. You're, you expect it to consume them relatively quickly. You don't have to, but at least that's the expectation that what will happen, most of the time. So going back to your question, like nodes have like a couple of purposes. One of them is the separation of state updates. The other important thing is how we treat them or how we've implemented them specifically for privacy reasons, because you do want to hide the transaction graph. You don't want to say, okay, this account has interacted with that account or something like that. So the nodes actually modeled more after Zcash, I would say, than after Bitcoin in some ways, because whenever you consume a node, you don't say I'm consuming this specific node. You have a nullifier that you consume, and the nullifiers are not linkable to original nodes. So like what the network sees, for example, is, okay, this account produced some nodes and this account has consumed some nodes. They don't know if those are the same nodes that were produced and consumed, right? So the linkability, like I can send funds to you and you will consume in a separate transaction, but like the network will not be able to tell that you're consuming my node versus any other node that existed at the time or has been created in the last whatever time frame. I think from the user standpoint, from the developer standpoint, well, from the user standpoint, it should be kind of fully transparent. Like users don't even need to know about the nodes existing or anything of that sort. So like we don't want to expose that level of detail to the end user. You still have like all of this kind of complexity is hidden away by the wallet software or whatever else. We have a few wallets already on our testnet that where you can see that. But basically, you receive an incoming transfer, the wallet claims the node, adds it to your account. You don't necessarily need to, like you can, one of the nice things about nodes, by the way, that you have more flexibility than you have with like existing models. I'll give you a few examples. It's a slight tangent, but I'll give you a few examples. First example is, frequently with Ethereum, like one of the annoying things is that people can just drop things into your wallet, right? Like you get tokens that you never expected or never asked for and things like that. And in this case, you have the choice to say, okay, I don't want to accept nodes that people send to me, right? You can whitelist some nodes that will get like, if somebody sends me USDC, fine. If somebody sends me ETH, it's fine. Like I don't need to like do any action, but like I can also say, here is a like set of like allowed types of assets that I want to accept, and everything else, like I want to manually decide whether I want to accept it or not. And so if somebody sends me an obscure token, I may decide to reject it and never get the node in the first place. The second interesting thing is that, and I should have mentioned this, nodes are fully programmable, right? So like they have like their own programs that get executed, and those are same programs as Miden VM can execute. And so you can put like different conditions on these nodes. So I could send a node to Pavel and then specify in the condition that only Pavel can claim this node. Or I could say, Pavel can take this node at any time, but if he hasn't taken it after 4 weeks, I can claim it back or something like that. And so I get this, what we call reclaimable nodes. And, imagine I screw up an address or something like that, which I'm always like, concerned about when I send transfers. In this model, like I could always, even if I screw up the address, I'll get the funds back, let's say in about a month time or something like that. So they're not lost because I can reclaim the nodes. I mean, again, there are trade-offs there because Pavel does need to claim the node in 4 weeks. Otherwise, I can reclaim it. But, for the most part, in most use cases, that should be fine. Like, I don't think we necessarily wait for 4 weeks or more. And, even if your use case is such where you don't know the time frame, you can increase the time frame by much longer, or even maybe not even have the time frame. The other thing is that we can do is like you can think about the nodes that could be consumed by anyone as long as they fulfill some condition, right? So I could send a node that says I want to trade some ETH for USDC, and I don't really care who consumes the node as long as like I'm putting, let's say, 1 ETH into this node, and as long as you send me, I don't know, like 4K USDC back, I don't care who does it. And then that creates like this atomic swap where anybody on the network can claim that node and fulfill it. Almost kind of like an intent, like, right? You can think about nodes as an intent to do something, and if somebody wants to fulfill this intent, they can do it, and I don't even need to know necessarily who the counterparty was for that in that transaction. Now, how does that look to the developer? I mean, it is a new development model, right? So you need to think about like, okay, this is my account, and we again try to simplify it as much as possible. So like, it's not a pure UTXO-based model where you need to think about like this low-level node, something like that. You define your account interface, and then you specify like, let's say, a node can call methods on this account interface. So you kind of code this in. Okay, this is an account, my actor, and this is a set of messages that this actor can accept, or how it will interact when it receives these messages. It's not new. Like if you code in the actor-based frameworks, that's how you do programming. But I would, say for sure not as many people are used to it as to, let's say, object-oriented programming, or like more if you code it in Solidity, for example, this is not a model that would be familiar to you. So there is a definitely learning curve.
Yeah, got it. And really great to hear that these notes are fully programmable. So developers, depending on their kind of use case they want to build, they can put different conditions or different constraints, I suppose. Like, for example, you mentioned the reclaimable notes. In the case, for example, if someone puts the wrong address, there's still a way for them to get back the funds and reclaim it. So it sounds like there's like a lot of flexibility that's offered in terms of the types of notes that can be tailored towards specific applications. So that all sounds great. And I also wanted to go back a bit back to the ability for offering both public and private transactions there, and then also in allowing for this hybrid shared public state and also self-custodied private state. I'm curious what kinds of applications can be enabled that can leverage both sides, both leveraging public state, both leveraging private state, that maybe some other types of approaches won't be able to support.
Yeah, definitely. So, private state is something that I think about could be used in a number of different ways. One of them is obviously like user wallets, right? Like a user can, there is no reason why my wallet needs to live on chain. It does come with some trade-offs, and I should get into some of this maybe a bit later on. Like one of the issues is like the private state management, because right, like if you lose your state, now the chain doesn't have your state, so you need to be very careful with how you manage your state locally, or you need to back it up, or you need to have a separate solution that makes sure that the state is always available for your wallet. I mean, for small wallets, it doesn't really matter if I have like a few $100s. I can probably just keep it on my device. My device probably is worth more than a few $100s, so like I don't necessarily care too much. If it's like thousands of dollars or more, I probably want to make sure I have like a backup solution for this. And unless it's like millions of dollars, probably a centralized backup solution is fine. But if it's like millions of dollars, I probably want to have some federated to decentralized backup solution where I may, make sure that not a single entity, like a single failure, will not like lock me out of my state and all of that stuff. So there is like challenges with this model, but for simple wallets, the solution here is relatively simple, and we're working with companies in the space to help us like build this off-chain components like OpenZeppelin and other Miden. We're working closely with them to develop some of this kind of auxiliary things that need to be there to improve user experience. But yeah, so wallets is one of the use cases where there is no good reason why I should keep my wallet on chain. The other interesting approach is that you can actually think about like off-chain apps that can run. And in fact, like you can think about every Miden account as like almost an L2 or L3 or whatever. It's like a separate. I mean, we don't think about it this way, but it could be a rollup or a Validium in and of itself. And so you could run like an exchange or a DEX where all the transitions are verifiable within the private account. Now, the rest of the network will not see it, so you may need to have some other solution, whether you want it to be a centralized or semi-centralized or federated. Like you will need to decide the specific design of your application, but you can actually just have it as being a full application, could be a Miden account. Now, going to the public state, I think why you need this is for things that require shared state, right? Because there isn't really a great solution for shared state. If I have something private and then other people, either I need to publish it somehow, but then that causes potential issues, or it needs to be public. And so things like oracles, for example, probably will need to be public accounts, right? So you want an oracle, so everybody should be able to read an oracle in their transaction. I shouldn't need to go to some entity to read an oracle and then depend on them to give me the latest state of the oracle or something like that. So oracles would be like, prime use case for public accounts. If you wanted to do like an AMM, for example, the fully like not managed by a specific set of actors, but fully like network level AMM, that would be probably a public account where you could still have your private wallets interact with a public AMM and still will not know like who is interacting. So you would see that there are trades happening within this AMM, but you wouldn't know who is sending the funds and who is receiving the exchanged funds back. So like DEXs could be done also as public accounts. I think there are quite a few other use cases that you can think that require some sort of registry. So like if you want to have like a public registry of like who can perform certain actions or like allow list or deny list or anything of that sort, it may need to be a public one where, okay, for me, like some kind of identity related things could be done where, okay, we verified that this account is, has done KYC, for example, and it could be encoded in the public registry. It could be, you don't need to reveal the actual information, but you may want to have that information available publicly so people can always access it. Now, I'm sure there are a lot of other use cases that I'm not thinking or not mentioning, but basically a lot of things that require shared state or you don't want to have people depend on a third party to get access to, that would need to live on chain. But a lot of things where it's my account or it's an application that I want to run with either centralized way, still verifiably centralized way. So like, just to make it clear, there is still a lot of value of me saying, okay, I'm going to run an exchange even as a centralized player where I cannot steal users' funds, right? Like, because I cannot like do arbitrary state transitions. So doing something like this in a private account makes total sense.
Got it. And yeah, it's really great to hear that you can even build use cases that, like for example, with the AMMs, you can build a public AMM, but then have private wallets interacting with it. So you don't really know like where exactly, say like the funds, like for which person it's attached to. So there's that privacy component that's preserved, but at the same time, the actual application itself is public for the AMM instance.
And I think one of the use cases that I didn't mention specifically for private aspect of it is treasury management or like in general kind of like fund management, right? Because a lot of treasuries and whether it's foundation or a whale or a VC or whoever, they live on chain, and it's also like every time the funds are moved and whatever becomes public knowledge. But this is not how like real world operates, right? Like if a real company has their funds in a bank, they don't necessarily want to see whenever they're making a payment or making a transaction. So like for things like treasury management of companies or foundations or investors or whatever, I think it makes a lot of sense to have like this private accounts that maintain this this level of privacy, but still allow these organizations to interact with each other and like do some trading in a way that is not fully transparent and things like that. I think this kind of leads to a bigger like kind of overall approach of how do we grow the blockchain pie, because I do think one of the next frontiers, and I think I don't think it's a controversial opinion now, is like institutions, right? You want to have businesses and institutions come on chain, and for them being able to stay private is absolutely critical. Like if Web3 degens sometimes are fine with like jumping through hoops and being like their trading activity be public or things like that. A lot of more traditional businesses and companies, I just cannot tolerate this, and so. Being able to cater to that segment is, I do think this is like absolutely critical for mass adoption of crypto to say, okay, I want to run a company, I want to put my funds on chain, but I still want to pay salaries and suppliers and all of that stuff, and I don't want this data to be, publicly traceable. I think this is a very, very important use case to unlock.
One additional question, just thinking about the use cases, I could be completely wrong on this point. But for lending, so like lending is like a one big use case that crypto has essentially gone on. I'm thinking on the utilization of notes. So you mentioned that atomic swaps are possible with notes. There's some aspect of programmability. I was wondering if those notes can be programmed in a way where people can essentially ask for collateral, or like these types of agreements where you would maybe deposit some form of collateral, and then if certain conditions, like for example, if the health rate of some type of asset is lower than based on an oracle, that could be then essentially liquidated. Are those possible within like the notes or the capabilities of notes, or would you need some type of like let's say to utilize the state management on the overall all blockchain, like how I guess I'm asking like how programmable are the notes when it comes to, let's say, that utilizing maybe like state data on chain versus just like on the node itself.
Yeah, I mean, they're extremely programmable. So like in a transaction where you consume a node, the node has like you can write a script for the node that is fully up to like the creator of the node to define, and that script can call and can read state of any account, can examine, like make specific calls. The one limitation is that it can update state of only one account, the account that is getting executed against, but it can read the entire state of the chain, can check the oracle or some conditions anywhere else, or like some specific account, and say, okay, did were funds deposited into this account, for example, and if so, then like this node becomes unlocked and somebody else can consume it and things like that. So it can check a large variety of conditions. I think one of the questions is how do you do it in a private setting so that it's easy if like all this information is publicly visible, and but you probably don't necessarily want to always reveal all the conditions of the loan, and in that case, like the node may be private. If the conditions of that the node depends on are public, that's almost trivial. If the condition that it depends on, okay, the state of a private account, that somebody else needs to, like at the time of transaction execution, say, okay, I know the state of this account. You can actually validate it because this is the correct state to execute against, but somebody needs to give you the state. So like, and this depends on the specifics of the application, right? Of like, how do we make that state available? Maybe there's a separate DA layer that makes sure that the state is available for this specific use case and things like that. But it is like, it is very, like I just haven't had enough time to think about all the potential uses of nodes, but you can think about like a ton of different things that you can, like one of the things that's not quite there yet, but we will have it in the next couple of months. What we're thinking is like making things even more programmable, where you can even attach programmability to specific assets, and you would say, can a simple example, and I'm not sure if it's useful, but maybe it is, but you can say this asset is tied to you being able to verify that you are over 18. And so unless you can verify that you're over 18, you can't own this asset, so to say. And so being able to impose conditions on asset transfers as well is very interesting. Defining assets as these units that you can kind of combine and merge in different ways, because right now we only have tokens and NFTs, but you can think about like this, talking about loans like a T-bill or something like that, that it has an amount, it has an interest rate and duration. And if I have two T-bills with the same interest rate and duration but different amounts, I should be able to merge them into a single asset and do things like that, which I think, I mean, again, I haven't thought through how useful it is, but it is very cool at the technical level to be able to do things like that.
Yeah, really cool to see the extensibility of the types of applications that could potentially be enabled. I think it gives a lot of flexibility and a lot of new opportunities as well. And in terms of the types of transactions that are consuming these nodes, I'm wondering if you can talk a bit more about the types of transaction modes that can be enabled with Miden. Like for example, I'm aware there's the kind of public and private types of transactions, which we were talking about before, and then also local and stateless transactions as well. By being able to enable both on-chain and off-chain data with both local and network execution, I'm curious to hear about the types of transaction modes that are being offered, and in what types of scenarios or use cases would it be ideal for someone to use one transaction mode over the other.
Yep, makes sense. I think so. Before I get into transaction, and I kind of alluded to this in the past already. There are different modes of keeping the state. So you can have the state on-chain or off-chain. So on-chain state means you fully put everything on-chain, and off-chain state means you put just a commitment to the state on-chain. So the hash of your state, which is actually different from a lot of other chains do it, or even the ones that kind of focus on privacy, because in those cases you frequently still put everything on-chain, just encrypted. In our case, it's truly off-chain, which, as I mentioned, comes with its own set of trade-offs. So you can choose to have state either local or public, and this goes for both for nodes and accounts. So you can have a private account issuing public nodes, or public account, issuing private nodes, and vice versa, and all of these combinations. In terms of transactions, you can think about transactions in two ways. There are network transactions and there are local transactions. And local transactions can work with both kind of private state as well as public state. And what I mean by local transaction is that a transaction that is generated by the user or an application, not by the network itself. So when I am doing a transfer, I will run a local transaction that updates my local state and create some nodes, and then I will send this to the network, and network will incorporate it. I could do the same thing with if I had a public account and that was managed by me. It would be the same version, just like I would put it on chain. If I, for example, for whatever reason, wanted everybody to see the contents of my wallet, maybe for transparency reasons or whatnot, I want to do that, so I would be able to do it, and then I can still run local transactions against that public state. It's just kind of the network will carry the state, but not the execution part of these transactions. And then there's a kind of the next level of transactions is the network transactions, where the network manages some account. And a good example of this would be an AMM, for example, right? So AMM is something that we don't want to update individually. So as I mentioned, I would want to send a node to an AMM, and maybe Alice, you will send a node, and maybe Pavel will send a node at the same time, but we can't create a transaction against the AMM contract because that will create contention. And in this case, the network will be executing these network transactions, and the network will be creating a transaction that says, okay, there are 3 nodes targeted to this AMM account. Let me put these 3 nodes into a single transaction, apply them, and then these nodes will be applied and generate the nodes that will carry back the exchanged assets, and then you, Pavel, and I can consume them in separate transactions, and those will be local transactions again. So this network transactions are super important because they allow us to cater to this, enable this operations with public shared state. And so at a high level, you have this network accounts that are managed by the network. You have public accounts that are managed by users or applications, but they're still public. And then you have private accounts that are managed by, again, users or applications, but they're fully private. And so against the first 2, you can execute, or against the second, the latter 2, you can execute the local transactions, and against the public network accounts, the network will build transactions by itself. And we have in our node, there is a separate component which we call a network transaction builder that will observe the network and build transactions based on kind of the activity that happens. And I think this is one of the also a fairly unique things about Miden that a lot of other projects don't necessarily have, where you have this ability to run things by the network itself.
Yeah, and it's great to hear all of those options that that the team offers. And yeah, it's also like very extensive as well with just going back to the applications, the types of applications, types of transactions that people can make during these applications, and then also on the application side, the in extensive variety that can be made. So I think it's really great that the Miden team took into consideration the flexibility option between using both like public and private states, and also like even developing a hybrid of the two. So it's really great how much flexibility is being offered here.
Sometimes I even think there is maybe too much flexibility. Like to give an example, like there is no enshrined signature scheme in Miden, right? You can use any signatures. You can even have accounts rotate their signature scheme. So you could, let's say, today use a CDSA and then switch to like a post-quantum secure signature scheme later down the road without changing the account or anything else inside of the account except for the specific part of the how authentication works. You could transition from a single SIG account to a multi-SIG account. You could do like there is almost unlimited flexibility, which is nice, but it also creates a challenge in the way that we need to come up with a sensible set of defaults. Otherwise, people get lost. And so one of the challenges for us is like making sure we have a sensible set of defaults defined from the start, where it's not kind of, okay, like I can do anything, but how do I do it? Versus, okay, here's how you would do it, how we would do it, but you can always deviate and build something own that we didn't think about.
Yeah, and it's great that you're having that consideration as well with providing those kinds of defaults. Yeah, as you mentioned, maybe sometimes in some scenarios, too much flexibility may be quite a challenge. So great that the team is also thinking on this point as well. And in terms of like other design considerations too, I'm curious to hear more about the Miden VM. So I know for the Miden VM, there's its own kind of design, like for example, consuming programs in the form of a mast, and then you guys also have your own program decoder as well. And I know from your end, you've had years of experience building these open source Stark-based ZKVMs, including Winterfell. So curious to hear if there's any kind of specific learnings that you had along the way that really helped shape the reasoning behind the design considerations that the Miden VM team took. Or like any other types of kind of reasonings, thinkings, like behind implementing like certain considerations for Miden's VM. And there's like currently quite a lot of ZK VMs in the market right now. So it's always great to hear like just the types of considerations that a team is taking and why they didn't make those same decisions that maybe another team makes. So wanted to hear from your side, especially since you had years and years of experience doing so.
I would say that Miden VM is quite a bit different from most other VMs out there, and like as everything, it has its own set of trade-offs. I think there are a few buckets of functionality that are very different from Miden VM as compared to to describe, like most other VMs fall into like a couple of categories, right? That you have ZK EVMs that basically prove EVM. You have RISC-V VMs now have become very popular that you're proving, and then there is some projects that like the ZK WebAssembly or maybe MIPS as well. So like, but by far the most dominant, I would say right now, is RISC-V VMs, and Miden is not a RISC-V VM, and so. It comes with its own set of trade-offs, right? Like, and the question is like, why did we design Miden VM, and why didn't we like do a RISC-V VM, for example, or why didn't we do a ZK EVM? So ZK VM is like, I kind of answered in, a little bit earlier, where I said I just couldn't figure out how to make the EVM work in a context of like this actor model and the asset model that we have. RISC-V, maybe we could have done it, and so like, is something that I keep thinking about, like should I have chosen like a more established architecture rather than coming up with our own. But I think there are a few important considerations. So for example, well, one of the things, to be fully honest and transparent, is that at the time when I started coding Miden VM, I didn't think RISC-V would be viable on the client side for foreseeable future, or something like general purpose instruction set to be able to prove it on the client side. So this was one of the reasons for trying to design something different to make it provable, like efficiently provable on the client side. I don't know. I don't think we're still quite there yet with RISC-V, but the progress has been much faster than I anticipated. So like, I have no doubts that in the next 3 to 5 years, maybe even sooner than that, we'll have like RISC-V VMs running on a smartphone as well. I was somewhat wrong on that in the efficiency consideration. I mean, still Miden VM to be exact is like if you need to run it in a low kind of computational environment, it's still probably is much better choice than RISC-V. But I don't think in a few years that necessarily will matter anymore. I think the other considerations for Miden VM that are different is, you mentioned one of them, is how we consume programs. And I think this is important in the context of privacy specifically. So we made a choice of using this mask-based approach, which means Miden is not even a von Neumann machine. So it's not it's a very different architecture that, as far as I know, nobody has used in the past. And again, inventing something new comes with its own set of challenges. But one of the advantages that we gain from that is, in our context, it's like, and I'm not going to go too deep into like the structure of master, how it works, but it's very easy to combine programs. It's very easy. You basically have what we call a content addressable calling convention, where you don't call by reference as you do like in most programming languages or VM architectures, where you specify a memory address of something you want to call. You call by hash. You say, okay, I'm going to execute a function with this hash. And the semantics of the program that you're going to execute are enforced by this. So you can't pass like a memory reference that will actually execute some unknown program. You always know what you're going to be executing, which I think is important in the context of like the security model that we want to have in blockchains. It also makes programs trivially composable, because you can take like, you can say, you think about it as a tree, you can like insert another kind of subtree in a different tree, and it's like very easily built into larger programs. So like when we execute nodes, for example, the way they invoke the contract code is like, almost trivial, and you get a lot of like flexibility from that. Another interesting property is the privacy aspect of it, where you can reveal parts of the program very easily, which is not trivial to do in other architectures. Usually you kind of have the entire program that you either hide full program or you reveal the full program. Saying, okay, I'm going to show you the beginning and the end of the program, but I will not show you what happens in the middle. And using the semantics as well, where like the middle part doesn't have the same privileged access as the beginning and the end. This is important for us when we like design like Miden transaction kernel and all of that stuff, where the beginning and the end usually is a well-known programs that enforce some constraints that the blockchain enforces, like you can't create assets out of thin air. But what happens in the middle is fully up to the user. And there's like the contract code can run as long as it complies with the set of constraints imposed by the kernel, so to say. And so this is also not trivial to do, or I actually don't know how to do it in other architectures, because a lot of this like context isolation usually enforced at the language level rather than at the machine level. And so we had to build this at the machine level. And then there are other things like efficiency. For example, as I mentioned, because of this master approach, you only pay for the code that you actually have to execute. So usually in the context of ZKVM, you need to unhash the code that, not unhash, non-deterministically unhash the code that you're about to execute. And usually you need to unhash the whole thing. In Miden VM, you actually just unhash the branches that have been taken. So you can imagine a large smart contract as an example, but every transaction calls only just a few functions on that contract. And so every transaction only needs to pay for unhashing the functions that it executed, not for the entire contract. And so this leads to efficiency. So overall, those were the main kind of reasons for us to still kind of stick with the different architecture. But as I mentioned, like the biggest advantage of going with RISC-V is you get the ecosystem of Rust that gets compiled to it almost trivially. They didn't need to build a separate compiler for to compile Rust programs, while we do need to take, so we have a bit more complexity and we need to build our own compiler. But overall, yeah, Miden VM has its, again, it's very interesting because it's so different from everything else that I've seen. But at the same time, I think we have a good set of reasons why we've chosen and to make it different.
Yeah, really cool to hear all of the kind of reasoning behind why these specific design considerations are made in the first place. Like you had the client side proving in mind earlier on, and that helped shape why you decided to have your own kind of like custom architecture. And then even with the efficiency improvements that you mentioned with the mask-based approach, like only unhashing what you're currently using and not the entire thing has some efficiency benefits attached to it as well. So really cool to hear, like even though Miden took a very different approach than what we see with a lot of existing ZK really great to hear some of the advantages that come with it, and then also just like the overall reasoning behind why those decisions were made in the first place. So that was really great to hear. And like even on the developer experience side, you mentioned that Miden currently supports a Rust-based compiler, and there's like a pretty streamlined compilation process pipeline that developers can take with their written Rust programs, compiling down all the way to like Miden assembly. So that's really great to hear. I'm just curious to hear if there's any other types of tooling or any other types of advantages that are on the developer experience side. I'm also aware that now users can target specifically the Miden IR and compile from their own compiler as well, which sounds pretty cool. So now there's the Rust compiler. I know you guys have a Wasm-based compiler, but there's also potentially support for their own kind of compilation process as well. So very curious to hear just any other kinds of things that you were thinking about, that the team was thinking about with the developer experience side.
Yeah, I mean, we are focusing on the Rust. I mean, there is other options, like technically anything you can, like there are multiple levels that if somebody really wanted to do it, they could like target Wasm, for example, and then compile Wasm. Like you could take C or C++, compile it down to Wasm, and then use our compiler to transpile it to Miden assembly. You could even target the IR that you mentioned. We have the kind of high, like this representation language that sits a level below WebAssembly in a way, where you can target directly that, but that like would be for very, very advanced users who want to build their own compilers. I think for now, like our main effort is going toward like just making programming in Rust as easy as possible. I think on the developer tooling side, like, I mean, there are a few things like how that we want to simplify. First, kind of on an educational aspect, right? Like just understanding how the model works. And for that, there's like we have like a developer playground, which is in progress and should be completed soon, which illustrates this node-based programming model where you can come, you can very easily create, like see how this, you create an account, you create nodes, how they interact with each other, how you execute transactions. And this is mostly for learning, and maybe this will evolve into something else, but it will give you a good understanding of how like the system works without actually having to install anything on your machine, because this could run fully in a browser and things like that. And then once you actually do want to do something serious, like we have the Rust compiler and like the ecosystem, like a set of tools that come together. Like there's an extension to a kind of cargo system that Rust uses for like build processes and all of that stuff that we have that simplifies building. We have like we're working on the project templates that will allow people to like start. Okay, I want to do a big part of this is okay. How do you write even a simple hello world program, right, in Miden? And so like working on the on tutorials and different scaffolding repos is gonna help a lot. Just the way things like that you have like Hardhat and Truffle and Foundry and things like that, they don't exist for Miden, right? So we need to write something that is equivalent. So we have like a set of tooling that we are working on that will allow you to like basically get the full tool chain for Miden, the client, the node, and run that locally, and kind of like you run your own blockchain for experimentation purposes. And that should come very simple, like with a few commands, you can start it up, like write a contract, deploy, see how it works, and all that stuff. So this is all kind of work that we're making good progress on right now. And then even beyond that, just like making programming in Rust ergonomic, because again, Rust is not a blockchain language, right? So like there is no concept of an account or a node in Rust. So and we have like ways that you can do it right now. It's just like maybe not as clean, and there's some boilerplate code that we need to abstract away from users and say, okay. And fortunately, Rust is like one of the reasons we chose Rust was because it's extensible enough where you can hide a lot of things behind macros, right? You can say, okay, we're going to write this macro, you attach this macro to extract, and this becomes an account. And now you can have full functionality of an account available from here on. And so a lot of this work is like, it's hard work. Like it's the things like, even the compiler, like how it works and like translates things from Rust to this must representation. Like it's not straightforward to do. And so, it's all in progress. A lot of this is like, in my mind, like 80 or 90% done, and we'll get much more done. One of the things I didn't mention is our timelines, by the way, is that we hope to go to mainnet as like Q1 next year and basically be code complete by the end of this year, so to say. And so like a lot of these things will, come together in the next couple of months. And so, getting the developer experience right is super important, because this is, one of the things that we do have like quite a few pioneers working on Miden right now, but, again, to be fully transparent, we know we can improve quite a bit on the developer. Like they tell us like, this doesn't quite work and this doesn't quite work, and like, or is more difficult than it needs to be. And so with every week, we're getting better and better. And I think besides writing smart contracts, just running this off-chain applications is something that people are not used to, right? So what we want to do, and we're working, and I mentioned like Open Zeppelin and Nethermind, is like to make this experience as easy as possible, where you don't need to think about private state management. There is a solution for you to, like, you can build your own if you want, but there's a solution that you can plug in that has been tested and audited and all of that stuff, and it works. Same for, we didn't touch on this, but there's like a node distribution. How do you do node distribution? Because for private nodes, only the hashes go on chain. You don't have the actual nodes. So like you need a separate layer that handles this private node distribution for you. And so this should be available out of the box as well. And, all of this stuff. I mean, there's almost too many things to talk about, but like all of this is like, we're very hard to work on.
Yeah, it's great to hear, like, on the engineering side, how much thought is being put in, and then also just on the end developers side, also with how many, like you mentioned, the playground, the tool chains, some SDKs as well, how much thought is being put there as well. So all parts of the stack are being addressed, which is really great to hear. And I'm wondering, just as a last question before we close today's session, if there's any kinds of announcements you'd like to make. I know you mentioned mainnet is coming pretty soon, so it's going to be a very exciting time. But curious to hear if there's anything else you'd like to mention, or even, like I ask all guests who come on this podcast if they have any sort of advice or any sort of like main takeaways that they'd like to tell the audience, especially any developers in the audience who are watching.
Yeah, I mean, in terms of announcement, I think, well, mainnet is Q1 next year. That's the goal. I think we'll soon transition to what we call like a public testnet, although our testnet is public already. You can like go and look at it and play around with it. I think kind of the more stable testnet where we we'll stop breaking things on kind of like semi-weekly basis will probably happen in, I'm hoping in about a month or so, and we'll have an announcement for that. Like I think we will, by the time this comes out, we hopefully will have an announcement for the compiler, the first version that is like working. And so there are quite a few, we have a packed several months of different things happening. In terms of advice, I think as it relates to Miden, I would encourage everybody to try to like do our tutorials and see how it works. I think it's an exciting model and try to learn. But in terms of like more general advice, I guess, and I think trying to deeply understand things, and like even if like doing things that people haven't done before, like not too afraid to do them. I think that's been our motto at Miden, like trying to not go with established paradigms, because like sometimes the established paradigms are, they're there and it's convenient to use, but sometimes if you want to go to the next level, you have to break them in many ways. And so not to be afraid to do that. Even back going to the ecosystem. Yes, ecosystem is a huge thing, for example, but I sometimes say it's like, you have at the time the carriages and cars, and the carriages had like a extremely established ecosystem, and the car was extremely difficult to use. There was no gas stations, no mechanics, nothing to use the car. And in the first probably several years or maybe even decades of car's existence, it was a more difficult thing to use than an existing carriage ecosystem. But in the long run, like sometimes you do need to like go through that pain to get to a point where you know, you wouldn't be able to get with the previous set of choices or designs.
Yeah, very good advice. And I know Miden has been the pioneer for a lot of different fronts. And yeah, it's always really great to hear about those projects who are kind of making their own kinds of choices. And even if it's completely novel, completely new, you mentioned that there's their own set of challenges, but experimenting with it and like choosing the specific kinds of constraints or considerations that make sense based on what you're trying to build is really great advice. So thank you so much, Bobbin, for coming on for today's episode. And yeah, I really enjoyed hearing about first Miden's design considerations, and then also on the chain side as well, the reasoning behind you guys developing your own chain, and then even on the developer experience side, what kinds of developments are being made on that front. So thank you so much for all the insights today.
Thank you for having me. It was a lot of fun.
Yeah, thank you.